Hi everybody, welcome back to HPC Tech Shorts, the engineering water cooler here in AWS. This is the third show in our series that we're doing with SchedMD, the maintainers and supporters of Slurm. So we're joined again by Nick Ihli in Utah. Hey Nick.
Hi, thank you.
And Austin Cherian in Singapore. Hey Austin.
Hey Brennan.
So if you want to get an idea about what's going on in this series, refer back to the first episode so that you can get some context for what we're doing. But we're actually showing you how to migrate your workloads from SGE to Slurm and how to do it in a nice, easy, and pleasant way. And we're learning quite a lot about a lot of tools that the folks at SchedMD have created inside the Slurm project that almost make it too easy for you to forget that you're using a different scheduler. That's going to become a common theme, I think. Anyway,
So today we're going to talking about using the scheduler in like a throughput mode. So basically job arrays. So all of our users, if they really truly want to take advantage of the parallelism that a cluster provides, then job arrays is your answer essentially. And I'll start by just looking at what an SGE job array script looks like. So maybe Brendan, if you can just bring up the graphic. Here we are, and essentially if you've been using job arrays, then this is typically what a very simple job array script would look like on SGE. Here we have 100 tasks, and essentially we also use the SGE task ID to kind of tag the task, and then off it goes into the queues. And it's really powerful in terms of, let's say, ensemble runs and things like that. So we have Nick here who's going to take us through that. So Nick, why don't you go ahead and give us an idea on this with Slurm?
Yeah, great. We highly recommend job arrays when you're dealing with massive throughput with millions of jobs. Arrays help in Slurm where you can submit millions of tasks in just milliseconds. Because in Slurm, when a job array comes in, it handles that as a single record, and it only kind of breaks out the individual tasks when that job is starting, when that task is going to start. So you're able to really handle quite a bit there. It also helps in optimizing backfilling in Slurm because it's not needed, because backfill is kind of a heavy operation, so it doesn't need to necessarily worry about all of the jobs. It knows if one of the tasks can't run, well, they're all like the same, so it doesn't necessarily, it can skip over all those other tasks. So highly recommend these. So let's talk about how to do arrays in Slurm. You saw there on the script that Austin was showing, SG has the -T option to determine your array size. It's a little bit different in Slurm. It's --array. Very, very simple there. Right now in this little quick demo I'm going to do, I am going to just do an array with 32 tasks, and I'm going to submit them to a specific node. The purpose of this is because we're in a cloud environment, if I did 1,000 tasks, we would be able to burst out to 1,000 tasks. And in this case, I want to limit to how many I'm currently running to show off a couple of things. And I'm just requesting one task or one CPU for each array. So let's go ahead and submit this. And now when I go and do my SQ, here we can see that these are the ones that are running, and the others are not broken out because they are currently pending. So Slurm is not like looking at them as an individual object necessarily at this time. So it's able to be a little bit faster. I could look at that SQ and do an -R, and that will show them broken out, but you see they're all pending. So that's why Slurm collapses them in. If I do an S control show job, as we've looked at this command before, let's look at 282_1. We can see that the job ID is 283. That's the real job ID for that array, that task. The array ID is 282, and the array task ID is 1. So if we look at a different one, let's look at 10, for instance, we will see that the real job ID is 292, but in all the reporting, we see it as 282_10. because 10 is that task ID.
Yep.
And so if I was to, let's take a look at this queue here. So we're just about done here. If I was to just do a quick, let's just do a quick SBatch job. Let's just get rid of all the array stuff. So we're going to do a normal job now. We'll see that the next job ID is not going to be 283. It's probably going to be in the 300s at this point. So the next job ID is actually 314 because all these do have a real job ID associated with them.
Great. And could you just comment on how, the control mechanisms once you start a job array? Are they the same, or is there something else that we need to take care of?
Yeah, so like from a scancel standpoint, I'm going to cancel a job. I can cancel a single task right there, and that one will go away. Looks like they've all just finished as well at this point. But I can also cancel the whole array as well. So you can have that control on individual tasks and even modify an individual task. How many resources they might need or something like that after the fact, or control the whole array itself.
Great, awesome. So yeah, I think this is again, job arrays is extremely useful, and again, used for ensemble workloads as well. And again, Nick, I guess there's some wrapper scripts over here as well for allowing us a more frictionless move, basically.
Yeah, definitely. So we talked about QSub before, the QSub wrapper script. We have the same option with arrays. So if we do a -T, which is what SGE would want, and let's do that 1 through 32, and then I'll do the SBatch line, which is going to show us what the Slurm SBatch output would be. We go ahead and do that, and we see that -T gets converted over to -- array. So we could go and submit the same one that we just did. Let's do that and get rid of the SBatch line and do that. And we look at the output here. If we did an SQ, we're going to see our new array set up. But then also, and this one, so this one is going to all our nodes. Let me actually show that real quick. So this is going to our 2 static nodes because we didn't direct it to a single node like I did in my first one. But we could look at QStat and we see this. Now, the only difference here is QStat's going to be showing the real job ID and isn't showing them broken out or collapsed with the task array there.
Got it. Awesome. This is great. So you get the same result at the end of the day, and it's somebody who's using SGE, he or she can get started almost immediately, basically. So this is great. And I guess we're going to talk about Slurm accounting. So maybe is there anything else on the job arrays, Nick, that you want to talk about?
Yeah, let's talk about the environment variables that have to do with arrays. That's important here. So here I've pulled up a job script that is going to similar to what we've shown before, same options. Here I have my array option, so I'm doing -- array, or I'm doing -A. So before I did the -- array, just doing -A here. But what I wanted to show is a couple of things specific to arrays. So one, in my output file -O, the %A is going to be replaced by the job ID, and lowercase %A is going to be the array index. So that my job 298 with my array index of 4, the job would be 298_4 for my output file. So that makes it really easy to help find the right output file there. And then similar to the job script that you showed with SGE, we also have specific environment variables for job arrays. So I have my Slurm array task ID. And so in this job here, I'm just going to be sleeping for 10 seconds and then echoing what my task ID is, and it's going to be the equivalent to this variable. And then I have a little job here that is going to pull in a data file that each data file has a specific number to it, and it's going to give me an output. And so let's just go ahead and I'll run this real quick here. So just do SBatch Let me make sure my queue is empty. There it is. Okay, so we'll do an S batch and do the array job. Job is running. It's going to be a pretty quick job. This is going to go to both of our static nodes. So if we look at those, they're all allocated for the job. This job should be very quick. We can look at SQ again.
Yep,
it's currently done. So let's go look at our output file. So we now have all these output files that have that job ID and the array index with them. And if we cat one of these, we'll see that it is, task ID is 27, and the data file I used was input 27.
Nick, Austin, thanks for coming along today. I think in the next tech short, we're going to be talking about job accounting. All right. Thanks, everybody. We'll look forward to the next episode.
Thank you.
Thank you.